We are taking a look at multiplying fractions symbolically. Now, in terms of our basic rule for multiplying fractions, we know that it's just the top of the first fraction times the top of the second fraction over the bottom times the bottom. So in question A, when we've got 1/2 times 3/5, we're going to do 1 times 3 on the top and 2 times 5 on the bottom. 1 times 3 on top gives me 3, 2 times 5 on the bottom gives me 10. 3/10 is in simplest form, that's my solution. For question B, likewise, we're again going to go ahead and do our top times top, bottom times bottom. 1 times 4 on top gives me 4, 2 times 5 gives me 10 on the bottom. Now we do want to go ahead and simplify that, so let's go ahead and simplify that. Both those numbers are even, so they do divide by 2, and that gives me 2/5 in simplest form. In the third question, when we're multiplying with a whole number, we want to remember that any whole number can be written as itself over 1, and then we can continue to use our same strategy. So we're going to do top 3 times top 2 over bottom 5 times bottom 1. 3 times 2 is 6, and 5 times 1 is 5. Now 6/5 is fine here. If you want to convert that to a mixed number and say 1 and 1/5, that is okay as well. In the final one here, again, we want to recognize that our whole number is itself over 1. We're going to multiply top by top, so 6 times 2 on top over bottom times bottom, 1 times 3. 6 times 2 is 12, 1 times 3 is 3. Now we do want to simplify here. Now notice, of course, that 12 is divisible by 3 and a fraction is just division. So 12 divided by 3 simplifies to the whole number, or the integer 4. Now, in questions with larger numbers, we probably want to look at simplifying before we do our multiplication, and this is called cross-reducing. Now, there's a few different things that we can do for simplifying. We can, of course, simplify any fraction where it already exists in the question. So, for example, in question A, I know that the fraction 6/12 simplifies by dividing top and bottom by 6. 6 divided by 6 gives me 1, 12 divided by 6 gives me 2. And I also notice that the second fraction can simplify by dividing top and bottom by 2. 2 divided by 2 is 1, 10 divided by 2 is 5. And by simplifying before we do our calculations, we just keep our numbers nice and small, and we have less reducing to do at the end. So on top, 1 times 1 is 1, 2 times 5 is 10. Likewise, in question B, I notice, of course, that I have my 6 over 8 that could simplify by 2. And my 3 over 12 can simplify by 3. 3 divided by 3 is 1, 12 divided by 3 is 4. And in the first fraction, 6 divided by 2 is 3, and 8 divided by 2 is 4. Now we can do top times top, bottom times bottom. 3 times 1 is 3, 4 times 4 is 16, and that is already in simplest form. The other thing we can do is we can cross-reduce, and this means that as long as we have one factor on the top and one factor on the bottom, we can actually go ahead and simplify those. And the reason for this is that the order of multiplication and division in BEDMAS doesn't matter. So let's take a look at that with this question C, and then we'll kind of look at the shortcut way that we can do it. We know that if we just followed our normal top times top, bottom times bottom strategy, we'd end up with this. But I also know that the order of multiplication doesn't matter. So 14 times 5 is the same as 5 times 14. And 25 times 7, I'm going to just leave alone for now. Okay. Now, by that same top times top, bottom times bottom deal, I know that this is the same as 5 over 25 times 14 over 7. And those are fractions that, in and of themselves, can reduce. We can go ahead and divide top and bottom of this fraction by 5 to get 1/5. We can divide top and bottom of this fraction by 7 to get 2 over 1. So that's kind of the long-winded way of doing cross-reducing. But really what we want to notice is because this order doesn't matter, you can simplify across the fractions. And that's what we mean when we say cross-reducing. You just have to have one factor on the top and one factor on the bottom. So if we take a look at question C, how I would probably do this question is I notice that 14 and 7, one on the top, one on the bottom, share a common factor of 7 that can be divided out. So I'd go ahead and say, well, I'm going to divide those ones by 7. And likewise, 5 and 25 share a common factor of 5 that can be divided out. So I'm going to divide those out as well. Now on top, 14 divided by 7 gives me 2. On the bottom, 25 divided by 5 gives me 5. On the top, 5 divided by 5 gives me 1. And on the bottom, 7 divided by 7 gives me 1. And again, the point here is just to keep our numbers nice and small. And now 2 times 1 is 2, 5 times 1 is 5, 2/5 is already in simplest form. Okay. It's not impossible to get the correct answer without doing your cross-reducing. You could just do your 14 times 5 over your 25 times 7. 14 times 5, well, 10 times 5 is 50, plus another 4 times 5 is 20. 50 plus 20 is 70. 25 times 7, well, 25 times 4 is 100. 25 times the remaining 3 is 75. But now we have to reduce 70 over 175. Now we can reduce that down to our correct answer of 2/5, but typically reducing at the start is a lot easier to see because they're within our times tables instead of reducing at the end when we have a lot of larger calculations to do. So generally cross-reducing or simplifying at the start is a very good idea. So we're going to take a look at question 3. I'm going to notice, of course, that I have a factor of 10 on both the top and the bottom that I can divide out. So I'm going to divide both of those by 10. Let's make this a little bit neater. And we're going to notice that gives us 1 on the bottom and 1 on the top. And 3 times 1 is just 3. And 1 times 11 is just 11. And that is in simplest form. For question E, there's a few ways we could go about doing this with our different values. Whoops, that's supposed to be a multiplication there, isn't it? Okay, let's correct that. We could go ahead and notice that both 16 and 28 divide by 4. So that might be something that we do. And I notice that both of these divide by 2 over here. So I'm going to choose to simplify inside those fractions. There are also other simplifications you can do across the fractions as well. So 16 divided by 4 is 4. 28 divided by 4 is 7. Over here, 8 divided by 2 is 4. And 14 divided by 2 is 7. And there's no other simplification I see there. So I'm going to do 4 times 4 is 16, and 7 times 7 is 49. And since these fractions don't simplify, I know that this fraction cannot simplify. Up here, again, a few different ways to think about this one. We have a variety of things that we could do. We could notice, of course, that both of these numbers divide by 5, and both of these numbers divide by 7. And that's what I'm going to do here. It's not the only thing you could do, though. The first fraction does share a common factor of 7 on the top and bottom as well that you could divide out. 35 divided by 5 gives me 7. 42 divided by 7 gives me 6. Oops, 6. And then 14 divided by 7 is 2. And then 25 divided by 5 is 5. Now there is some additional reducing I can do here. If you notice that both 6 and 2 can divide by 2. And that's going to give me a 3 on the bottom and a 1 on top. And I think now I'm fully simplified. And so I'm just going to do top times top. 7 times 1 is 7. And bottom times bottom. Let's make that a bit neater. 3 times 5, 15. Now, if we are working with mixed numbers, we want to remember that a mixed number has implied brackets. 2 and 1/2 is really 2 plus 1/2. And so that plus has to be done because this is a single value, 2 and 1/2. It's not just 2, it's not just 1/2. It's a single value of them together. And so we want to pay attention to the fact that we need to do a conversion of these mixed numbers into a improper fraction prior to actually doing our multiplication. And the reason for that is that brackets implied by that mixed number come before multiplication in BEDMAS. So let's remind ourselves that, of course, 2 is really 2 over 1. We're going to multiply top and bottom by 2 to get a common denominator of these fractions, and this gives me 5/2. Now, the shortcut way of doing that is multiply your whole by your bottom and then add the top. 2 times 2 is 4, plus 1 is 5/2. And then our second number already was a fraction. I don't see any cross-reducing we can do here, so let's go ahead and just multiply top by top. Bottom times bottom. 5 times 1 is 5. 2 times 9, 18. And since I couldn't reduce anywhere earlier, I know that these won't reduce either. Oops, we're having trouble making our box, though. Question B, we're going to recognize that 4 is 4 over 1. And we're going to convert our mixed to improper here. 2 times 8 is 16, plus 3 is 19/8. And that's what we want to multiply our 4 over 1 by. I do see some cross-reducing I can do here, so I'm going to divide out the common factor of 4 in 4 and 8. 4 divided by 4 gives me 1, 8 divided by 4 gives me 2, and everything else is the same. 1 times 19 is 19, and 1 times 2 is 2. So 19 halves is acceptable there. If you want to convert that into a mixed number, 2 goes into 19 9 full times with 1 half left over, and that would be an acceptable answer as well. Okay, it doesn't matter if both of our numbers are mixed numbers. We do want to convert them both to improper. So 1 times 5 is 5, plus 4 is 9 fifths. And then 2 times 4 is 8, plus 3 is 11 fourths. I don't see any cross-reducing we can do here. So we're just going to go ahead and multiply top by top, bottom times bottom. 9 times 11 is 99, and 5 times 4 is 20. We can say 99 over 20 as a improper fraction. If you want to convert that to mixed, you could also say 20 goes into 99 4 full times with 19 twentieths remaining. Now, we can apply those ideas to a few other skills that would be quite difficult to do without our fraction multiplication, and one of those is working with repeating decimals. We know from conversions that a repeating decimal is that digit over the number of nines. That's the same as the number of digits that repeat. When we take a look at our 0.6 repeating, we know from our conversions unit that that's just the fraction 6 over 9. One digit repeats, so 1 9 on the bottom. What digit repeats? It's a 6. We also know that our whole number 9 up front is just 9 over 1. I'm going to notice that both 9 and 9 can share a common factor of 9 to divide out. That gives me 1 over 1 times 6 over 1. 1 times 6 is 6, and 1 times 1 is 1. 6 over 1 is just the number 6. Okay. This would be difficult to do as a decimal multiplication because 0.6 is 0.6666666666666666666666666. You go on forever, and I'm eventually going to multiply all of that by 9, except that I'd be writing out these 6's forever, and I'd never actually get to multiplying by 9. Each time I did, I have 9 times whatever 6 I eventually give up at is 54. The next 9 times that is going to be 54, and blah, 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 so on, so on, so on, and so forth. Okay, so much easier to do with fraction multiplication than it is with decimal multiplication. I mean, you never finish the decimal multiplication because it goes on forever. Okay, same thing over here. 0.8 repeating is 8 ninths as a fraction. 0.6 repeating is 6 ninths, as we earlier said. And I'm going to go ahead and just divide out the common factor of 3 in this fraction, just to simplify a little bit. 6 divided by 3 gives me 2. 9 divided by 3 is 3. And I think that's about all the simplification I can do. So I'll just do top times top, bottom times bottom. 16 over 27 is going to be my simplest form factor. If we have 2 digits repeating, of course, that's going to require our 2 9s on the bottom. So this is going to be 54 over 99 for 0.54 repeating. And this is going to be our 36 over 99 for 0.36 repeating. Again, I'm going to do some simplifying here. So I'm going to notice that both of these can divide by 9. And that's going to give me 6 over 11. And then over here, both of these can also divide by 9 as it happens. And that'll give me 4 over 11. I don't see any other cross-reducing I can do, so I'm just going to do top times top, bottom times bottom. 6 times 4 is 24, and then 11 times 11 is 121. Since I didn't have any reducing up here, I know that there's no reduction possible with my 24 and my 121. Okay. Now, for our final one here, our 1.06 repeating, I want you to remember that this is 1 plus 0.06 repeating. 1 is just 1. 0.06 repeating is 6 over 99. So this is actually a mixed number, 1 and 6 over 99. And we could, of course, convert that to a improper fraction, or we should convert that to an improper fraction. And 1 times 99 is 99, plus 6 is 105 over 99. And we want to multiply that by our other number here. In a similar way, we're going to say that 4.3 repeating is 4 plus 0.3 repeating. 0.3 repeating is 3 over 9. And that's really the mixed number 4 and 3 over 9. I'm going to go ahead and recognize that 3 over 9 is 1/3, just to keep my numbers smaller. 4 times 3 is 12, plus 1 is 13 thirds. And that's what I want to multiply that by. Now if I take a look, 1 plus 0 plus 5 is 6. 6 is divisible by 3. So I can either divide it out with this 3 over here, or I can divide it out with the 99. Either way, I'm going to divide out a common factor of 3. 3 goes into 10 3 times. 3 goes into 15 5 times. 99 divided by 3. 3 goes into 9 3 times. 3 goes into the other 9 3 times. That's 35 over 33. And then that's times our 13 over 3. I don't think there's any other factors that we can eliminate. So we're just going to do our top times top, bottom times bottom. We get our 99 back on the bottom, and 35 times 13. Let's take a look. 3 times 5, 15, carry 1. 3 times 3, 9, carry 1. Placeholder 0, 1 times 5, 1 times 3. 455, I believe. Check if that makes sense. 35 times 10 would be 350, plus another 105. Yeah, 455. Again, since I didn't have any simplification possible over here, I know there'll be no simplification possible at the end. Okay, so you can apply these ideas to all of our other questions, which might just require different levels of cross-reducing. But hopefully this helped you with the basic idea of using our fraction multiplication symbolically.